Hi everyone, welcome to the next video in our Verilog series. So in the recent times, I have observed so many students messaging me having a confusion between the logical operators and the bitwise operators in Verilog. So I thought I wanted to dedicate a separate video on this particular thing. So in today's session, we are going to discuss about the difference between means how the logical operators do work in Verilog. So how the logical operators work in Verilog. Why am I specifying in Verilog? Because I don't wanted to go into some other things. Okay. So generally, we are aware of the fact that there are three different types of logical operators: logical AND, logical OR, and logical NOT. These are quite different. These are nothing but in the logical. But when you come to the bitwise, this is represented by AND, OR, and NOT. Okay. So this is the first and primary difference between the bitwise and the logical operators. Now let us take a corresponding examples and let us try to analyze how this particular bitwise or logical operators are working in Verilog. So in order to take it, let us consider 1000 1111. Let us consider two operands and let me consider the logical AND operation behind it. Okay. So generally in the regular perspective, the student's perspective will be like the student perspective. Okay. So here 1000 and when I'm calling 1111, so this is going to be 0. Sorry, yeah. This is going to be 0 and this is going to be 1. Okay. But this is nothing but the bitwise operator, bitwise AND. But that is not how the logical AND is you should work. So logical AND will function like, for suppose 1000 and 1111. So generally here you can see that as 1 is there in all the bits, whatever the bits are there on the right hand side, RHS, and let me call this one as the LHS, the left hand operand and the right hand operand. The RHS, we are having all the ones. So the compiler will assume this corresponding values as 1. And here also, if at least 1 is there, the compiler is going to assume this one like 1. And when there is an AND operation, 1 and 1, which will lead to 1. Okay. So from this, the important point which we have learned is, if any one bit of 1 is there, the compiler will assume all the values to be of 1. Okay. Now, in order to understand this, let us take one more example. Okay, and let us also do the coding parallelly. So let us write a very small code. 13. So module test and module. So let me take two operands, reg 3 down to 0, a comma b, and let me take one more operand, reg 3 down to 0, out. So let me take an initial, begin, and the end block. So here let us consider out is equals to a and b, and before declaring this, I think I need to mention the values of a and b. A is equals to 4 tick b 1000 and b is equals to 4 tick b 1111, And now let us print the result. Let me use dollar display. Out is equals to percentage b comma out. Okay. So now let me run this. So yes, here I got the values of out as 0001. Why? Because I have mentioned the out to be of 4 bits. But in the logical operators, the output has to be surely 1 bit. So that's the reason I'm just making this one like 1 bit. So now you can see that the out value is 1. Okay. So now let us take one more example in order to understand this. So let me take the LHS operand value to be of all zeros and the RHS operand value to be of 10000. Okay. So here there is no 1. In the earlier example there were 1. So it has taken the 1. Here there are no 1s. So automatically the compiler will assume this value to be as 0. And as there is at least one 1, the compiler will assume this value to be of 1. Okay. And when I'm doing the AND operation, 0 and 1 should result in 0. So let me check whether I'm getting the same value. So let me take it as 0 and let me consider here all the 3 are 0. Yes, that is the same example which we have assumed. Now let us try to analyze this part. I think, yeah, sorry, I think I missed the semicolon. Mm. Yes, we can see that whatever the out value is 0 is same as whatever we have got it. Okay. Now, let us try to analyze this scenario in still more a different way. Now, let us try to introduce some don't cares. Okay. So, here let me consider 100 don't care and 1111. Okay. So, even though the don't care is present, as I'm having the 1, the compiler will assume this one like 1. And here also, as I'm having the 1, the compiler will assume this one like 1. And when I'm doing the AND operation between these two, the compiler will throw me the value 1. So let me check whether I made a mistake or not. So let us consider this value to be of 1100 don't care. And this is going to be 1111. So let me run this code. Oh shit, I'm sorry. Hmm. Yes. So we can see that whatever we have assumed theoretically, the same thing we got it even in the simulation. Okay. Now let us try to assume one more condition where 000 don't care and 1111. So this 000 don't care will result in, so here no one is there, only zeros are there and a don't care is there. So automatically the compiler will result it in a don't care. It will not consider it as one. Only if one is there, one will come there. So here this compiler will assume this one like 1. So 1 and don't care will again result in a don't care. Okay. So let us check it. So let me consider this one like 000 don't care and 1. Now you can see that yes, the result is don't care. Okay. So this is how this particular logical operators will be working in the Verilog. So let us write down a brief summary, because for a person who is listening this for the first time, they require a summary. So brief summary or points to remember. So the first one, for the logical operators, the output will be 1 bit for logical operators, 1 bit for logical operators. The second one, so if at all at least one is there in an operand, if at least one is present in an operand, the result will be considered as, the compiler will assume the value of the operand as, the compiler assumes value of operand as 1. Okay, so this particular condition, even if a don't care or high impedance is present in an operand, and at least one is present, the compiler will consider the output to be as 1 only. That particular value of that particular complete operand is assumed as 1 only. Now, let us write down one more point. So, if no one is present, one is present in an operand, and only zeros are present, zeros are present, the compiler assumes value as, compiler assumes value of operand as 0. Here a point to add, if don't care is present, don't care or high impedance, anything, or high impedance is present and no zeros are present and no ones are present, the compiler will assume, the compiler will assume the result as don't care only. Even though if high impedance is there also, the compiler will assume the result as don't care. So these are the three different points to remember while using the logical operators. So the result will be same, means whatever the logical operation will be dependent upon the corresponding gate which we are using. But here we need to be very careful while using this logical operators. So thanks for watching. Please do ping us in the comment section below to make any changes, or for any advices which you want to give it to us. And also if you are having any ideas in your mind, please do ping us. I'm ready to do the video in that particular thing. Thanks for watching. Thanks for your time. We'll meet you in the next video. Thank you.